Welcome to the presentation on longest palindromic substring. This is a solution to the problem using an efficient approach. Let's dive in. In this problem, we are given a string S and the task is to find the longest palindromic substring within S. A palindrome is a string that reads the same forwards and backwards. For example, given the input string BA, the expected output could either BAB or ABA. Before we proceed, let's quickly review that a palindrome is a word, phrase, or sequence that reads the same backward as forward. For example, MADAM, madam, is a palindrome, like hello is not. Let's now talk about the approach. The key observation here is that a palindrome has a center of symmetry. So we treat every character and every pair of adjacent characters as potential centers. There are two cases to consider: odd-length palindromes which have a single center character, even-length palindromes which have two center characters. We expand outward from each center, comparing characters on both sides to see if they match. If they do, we continue expanding until we can no longer form a palindrome. This process is repeated for every possible center in the string. Here's the plan. For each character in the string, treat it as a center of a potential palindrome. Expand outward to check for both odd and even length palindromes. Track the start index and length of the longest palindrome we find, and return the longest one at the end. Let's now look at the code. In the function longest palindrome, we initialize two variables: start to store the starting index of the longest palindrome and max length to store its length. We iterate through each character of the string to check for palindromes centered at that character. For each character, we call the helper function expand around center to check for both odd and even length palindromes. In the loop, for each center, we calculate the lengths of the potential palindromes. We compare the lengths and update max length and start if we find a longer palindrome. This continues until we have processed every character in the string. The helper function expand around center takes two parameters, left and right, which represents the current center. The function expands outward as long as the characters at the left and right match, and it returns the length of the palindrome. The function keeps track of the largest palindrome it finds by adjusting the left and right indices. Let's walk through an example. We take the string BABAD. For the first character B, we expand outward to check for odd length and even length palindromes. We find an odd length palindrome B and no valid even length palindrome. Next, at index 1, we check for both odd and even length palindromes centered around the character A, and we find a valid palindrome ABA and BAB. Moving on, at index 2, we expand around B and find the palindrome BAB. At index 3, we find the palindrome ABA. Finally, at index 4, we only find a single character palindrome D. After checking all the characters, the longest palindrome is BAB or ABA, which are both valid results. Let's now analyze the time and space complexity. The time complexity is B go of n square because for each character we expand up to n by 2 characters to check for palindromes. The space complexity is big of 1 since we only use a few extra variables to track the longest palindrome. In conclusion, the expand around center technique is an efficient way to find palindromic substrings. While the time complexity is big of n square, the algorithm works efficiently for typical string lengths. This method solves the problem with constant space usage. Thank you for your attention. Do you have any questions about the solution or the approach?